Okay, chapter 11 is vectors, and a lot of it is from GCSE. I'll run over the key points, but mostly it's going to be things that we've seen before. So if you've got something being described as A, so you have the vector O to A is A. If you go against that, so in the opposite direction to A, it's just minus A. So there's a parallel, in the opposite direction is just negative. Speaking of being parallel, if two vectors are parallel, then they are scalar multiples of each other. The scalar is just a number without a direction. So vector is magnitude and direction, scalar is just magnitude. So what that means is you can just think of it as being a number. So here I've got 2a, it's just 2 times by the vector a, which means they're parallel. That's true if it's just a, or if it's like a multiple of a, it's going to be parallel to it. If it's a minus b, then 2a minus 2b would be parallel to that. If you can factorise out a number and the vector part is the same, then that is they're parallel, it's the scalar multiple. Top and tail is the way of getting, one way of doing vector addition is normally the geometric way of doing it. So if you've got anything on a graph, a lot of the time this is how it goes, or even anything with a fancy shape. I say a fancy shape, that's a parallelogram. But if it's like a geometric question, very often you combine vectors by adding them, and you just do one followed by the other. So that's 2a, that's b. So to go straight from c to e, it's 2a plus b. It doesn't matter which order you go in, or which way you go to get there. If there's multiple ways, c to e is always going to end up being the same vector. This is very useful. You can see it makes a triangle in doing questions which are geometric, where you know you're always going to end up doing things like Pythagoras, trigonometry, stuff like that. Even more so than when it's A and B, you will see that with stuff on a graph. So when you're doing things on a graph, or north, east, south, west, so if something is like a map or you've got compass directions, they tend to use these IJ, I is horizontal, J is vertical, or a column vector. So if you ever see anything to do with IJ or a column vector, very often you're going to be doing some of these things. Finding the length of a vector, or a combination of vectors, is as simple as doing Pythagoras. That's how you do the length of anything on a graph, is by using Pythagoras. You want to know the coordinates, or in this case, just that's the vector to get from O to A is 4, 3. A's position vector would just be the coordinates 4, 3. So you can just do Pythagoras to work out the length. And that's true for anything on a graph. So Pythagoras comes up again and again and again. Hopefully you've noticed that by now. Angles, you're just going to use basic SOHCAHTOA. So look for it. If something is an awkward triangle, like the one here, OAB, maybe that's an awkward triangle, you can still work out this angle by using trigonometry, just basic SOHCAHTOA, and you can work out this angle by using basic trigonometry. It's just tan, if you know what B is. I haven't written down what B is because that's not what I was going to talk about, but if you know what B is, you can work out this angle by doing tan, and then you can just work out, because it's on a straight line. So a lot of the time you're going back to basics with these Pythagoras, SOHCAHTOA. In this case, that theta is just inverse tan 3 over 4, opposite over adjacent. This is a unit vector. Normally they don't use this symbol, but they might just call it a unit vector. A unit vector is a vector of length 1 in the same direction as the original vector. So all you have to do is work out how long it is by doing Pythagoras, and then divide the vector you had to start off with by that. So the length of this vector is 5, you just divide this by 5. So 4 over 5, I, plus 3 over 5, j. And if you did Pythagoras on that, you'd see that it was a length of 1. I think that's everything. You can just see more and more triangles. So if something is an awkward triangle, you can't easily work out the angles using SOHCAHTOA. You can always use cosine rule, sine rule. If you ask for the area of something, you can use half AB sine C. Those things come up again and again and again on graphs. Going to the intermediate things, I'll put bearings in here because it's just another thing to remember, but it's going to be the same thing again. It's using Pythagoras, it's using trig. Here, if you've got angles, you can add them together or take them away going from north, going round. So here you've got an angle. If you know A and B, like as vectors, you can work out what they are as in terms of a length by using Pythagoras. And then you've got two sides and an angle of this triangle here. So you could work out that length, or you could work out that angle or that angle, right? You can use those same cosine sine rules for vectors as you did just for normal shapes. The other thing that's in there I've put is ratios, anything where there's a ratio. I'll put a kind of odd one here. Normally they give you A to B and B to C as a ratio, but I've done A to C and B to C as 5 to 3, which means that the whole length is 5 compared to BC, which is 3. So this means that bit's 2 and that bit's 3 and that bit's 5. Here I've put in, I didn't say it here, if you've got position vectors of A and B and you want to get from A to B, you just do B minus A, B being the position vector of B, A being the position vector of A. So they normally use capital letters for the point and then lowercase letters for position vectors. So if you want to go from A to B, it's just B minus A. Same thing here, if you want to go from A to B, it's B minus A. That gives us AB. AC is going to be 5 halves of that, because this bit's 2 and this whole thing is 5. So it's going to be 2.5 times longer to get from A to C because they're parallel. And then B to C is going to be 3 halves of that, because if this is 2 and this is 3, then it's 3 over 2 times by the length of it. Sometimes they'll do that and they'll say that they're parallel or they're in a straight line. If things are in a straight line, they are parallel by definition. So use the fact that you know it's going to be parallel, so it's a scalar multiple. As one of the basic skills. Advanced, this is in the textbook. It could come up. I've never seen it come up. Anything with an intersection could come up. It's more likely to come up in year 13, but even then the questions tend to be kind of 2, 3, maybe 4 marks, whereas a question like this you'd expect it to be maybe like 7 marks. So they've never come up, but if they do happen to come up, then just remember it's the same thing as GCSE. If you're doing something with an intersection, and what you want to do is find 2 different paths there. So if I've got D to P, that's one path, that's a fraction of dB. So just use a letter as the fraction. So like x dB. And then find another path that goes through the other diagonal. So D to A, and then a fraction of A to C. Put those 2 things equal to each other, and then this is going to be more useful next year. But when you have a vector equation, normally you've got 2 parts. Next year there'll be 3 parts in 3 dimensions. But you've got an I and a j. The I parts are equal and the j parts are equal. So you can make 2 equations, simultaneous equations, and solve those by splitting the I parts from the j parts. If you're doing it in column vectors, then it's as simple as the tops are equal and the bottoms are equal. So you can write 2 equations like tops are equal to bottoms. And I think that's it. These questions can be quite awkward. There's a couple of them in the questions that follow, but if you follow that, kind of find 2 different paths that go along the 2 different diagonals, equal them, equate them, and then solve them simultaneously, the I part and the j part, or the A part and the B part. Normally you work with a vector, often there's A parts and B parts. So you put the A parts all as one equation and the B parts as a separate equation, and then you've got 2 equations you can solve simultaneously. But that's it. Enjoy.